In this lecture, we're going to be doing some scope analysis on the switch statement that we have learned about in this chapter. In the examples we have seen so far, we have always used curly braces to wrap the code for each case in its own block. And that was really cool because the code was really readable. It was easy to see which code runs in which block. But I want to bring to your attention that it is also possible to do things like this. If you look here, code for each case is really put in without any curly braces, and this is going to work as we expect. For example, for case 0 here, we're going to run the first statement here, we're going to run the second statement, and we're going to hit the break statement, which is going to throw us off the switch block here, and things are going to work exactly how we expect. So this is one way we can do this. But I didn't show you this by default because curlies make it really easy to see what is happening in each case, and I recommend using them if you can. But know that this is also an option and it is going to work, and we're going to try this out in Visual Studio Code in a minute, and you're going to see that it is going to work pretty well. Okay, now we want to do scope analysis on our code in our switch block. One thing you should know beforehand is that the code in each switch block lives in the same scope. Let me repeat this. The code inside our switch block is going to live inside the same scope. That means if you declare a variable x like this, you're going to be able to use it in case 0, for example. You see we are doing x equal 4 and we are incrementing this even if this x variable was declared outside any case. And if you look here, we are declaring an integer variable y in case 0, but we are using y in case 1, and this is going to compile and work really fine. Again, if you go down in the default case, we are using the z variable, which was declared in case 1, and this is really going to work. And this hopefully drives the point home that our switch block is really one scope. So the variables you declare in the switch are going to be visible on any case. But one thing you should know is that you can't try to use a variable before its point of declaration. So for example, in case 0, if we try to use the variable z, we're going to get a compiler error because it is declared in case 1. So if we really want to use z in this switch block, the starting point where we can use it is after the declaration point in case 1, which is this line here. So after this, we can use z safely in this switch block, and it is going to work. But if you try to use z before it is declared, you're going to get a compiler error. So the main message here is that our switch is one giant scope, and everything inside is going to be basically in the same scope. But if you are careful, you're going to notice that we didn't really initialize our variable. So let's try to initialize them and see what is going to happen. Let's take x here and initialize that to a 5, y to a 4, z to a 6, and u to an 8. And you see that I have put in a few comments to give you a hint of what is going to happen. So why do we have all these compiler errors? Why can't we declare variables inside our switch block? Well, the problem is that we can't guarantee that the statements to initialize these variables are going to run. For x, we are pretty sure that it's never going to run because in a switch block, the only code that runs is code that lives under these cases. So code in case 0 has a chance to run, code in case 1 has a chance to run, code in the default case has a chance to run, but code before any case will never run. So this variable will never be initialized. So what's the point of trying to initialize with a statement that is not going to run? And the compiler is going to detect that and stop you from doing that, because otherwise you would end up with a value that is not really initialized and try to use it and get bad results, and the compiler is going to stop you from doing that. Okay, so for x, it is really clear. But what about y? Y is going to run if we have a case 0, for example, here. But we can't guarantee that case 0 is always going to run. So if our condition here is 1, for example, we're going to jump to case 1, and case 0 is never going to run, and y is not going to be initialized. And if we try to use y in case 1, like we are doing here, we may get a compiler error because we may try to read the value that is in there but case 0 was never run to initialize y in the first place. So hopefully you can see some crazy problems that may come up if the compiler allowed you to put some initialization code inside the cases in your switch statement. The compiler is going to stop us from doing that because we can't guarantee that the code to initialize the variable is going to run. And if you try to use a variable that you didn't initialize in the first place, bad things might happen. You're going to get garbage in there, and we can guarantee that you're going to have a lot of problems. So the compiler is being helpful here and stopping us from doing this. If you look down here on this default case, we have a variable u, it is initialized, and I say that this is okay. So why? Well, the default case is always going to be last in your switch statement, and there really is nothing that is going to run after it. So there is not going to be anything that is going to depend on what we initialize in the default block here. So that's why the compiler is going to be okay with us initializing here, because we can't have all those crazy problems of somebody trying to use the u variable because there is no other case after the default case. I really hope this makes sense. And this is really all I wanted to show in this lecture. Again, a switch block is one giant scope. We have a few parts inside. We have the code we run before any case runs, which is green here. And we have different code blocks for different cases we have in the switch. And we have the block for the default case. So this is what we have here. Okay, if you are wondering, how is it possible that we are able to see the variable y inside the case 1, even if this variable was declared in case 0? The reason this works is that all the code for declaration is actually moved by the compiler before any case runs. At the point when we start running any cases, all the variables are going to be already declared, and we're going to be able to use them provided we don't try to use them before the point of initialization. That's a limitation that is imposed by the compiler to stop you from doing crazy stuff. But you can think that all the variables are really declared before our cases, just like we have the variable x here. So the compiler is going to take all these declarations and move them before any case runs. So int y is going to move to the top, int z here is going to move to the top, int u here is going to move to the top, and the compiler is going to stop us from using any of these guys before their point of declaration. So again, if we try to use z, for example, in case 0, it's not going to work. The compiler is going to stop us, but it's not because this variable is not declared yet. It's a limitation that is imposed by the compiler. Hopefully by now you can see that declaring variables and trying to make them visible in different cases in a switch block is really crazy and dangerous business. That's why I really recommend you don't do this. If you need to have a variable that is going to be visible across different cases in your switch block, I would recommend using an initializer, or even going as far as declaring a variable outside your switch scope so that it is visible in any case in your switch block. This is going to be much cleaner, and you won't have to deal with all this craziness we have in switch scopes. This is really all I wanted you to know in this lecture. Now we're going to head to Visual Studio Code and actually play with this. Okay, here we are in our working directory. The current project is switch scope here. We're going to copy the files from our template files, and we are going to put them in. And we are going to open our project in Visual Studio Code. We're going to choose it and open it. Okay, we are here. We're going to get rid of what we don't need. And we're going to put in our int variable, which is going to be our condition. And we're going to initialize this with a 0. Why not? After that, we're going to put in our switch block, and we're going to let Visual Studio Code help out. We're going to be switching on this condition, and we're going to put in a few cases. The first case is going to be 0, and we're going to put in a few statements. Let's put in another case just to make sure this is not too small. So we're going to put in a case 1, and we're going to call this 1, and statements are going to be 3 and 4, and we're going to put a bunch of statements inside the default block. Let's do that, and we're going to call these 5 and 6 just to simulate something running in our cases here. And this is going to show that we can actually use a switch block without putting curlies in like we've been doing all along. Remember, in what we've seen so far, we were doing something like this. Let's copy this and put that in place here. We were doing something like this, but you can leave out these curlies and it is going to work. So let's take this out again and tidy this up a little bit. And it is going to work. If we try to compile and run this, condition is 0, so case 0 is going to run. We're going to see statement 1 and statement 2. Let's bring up our terminal. We're going to build with GCC, and after we do this, we will have to open our own terminal. And if we run Rooster, we should see statement 1 and statement 2. That's what we get. If we change the case to 1 and build again and run, we're going to get statement 3 and statement 4, which is what we have here. If we put in some other value, the default case is going to run and we're going to get 5 and 6. So let's try this out. We put in an 8, for example, we build again, and we run Rooster. We're going to get a 5 and a 6. This works as expected, and it is basically going to run each statement until it hits the break statement here, and it is going to jump out of our switch block here and execute whatever is outside here. So let's say move on, like we've been doing all along, moving on. And if we change this back to a 0, for example, and build, we're going to see statement 1 and statement 2, and then we're going to see moving on. Let's see if the build was good. The build was good, so we can clear and run Rooster. We're going to see statement 1, statement 2, and moving on. Okay, hopefully this makes sense that we don't really have to put curlies in there, but they make code easier to read and understand. So I do recommend always putting them in there, but you are definitely going to see code like this out there. That's why I am explaining this here. So the second thing we want to look at is how we can share variables between different cases by declaring them in different places. So what we're going to do, we're going to go in our switch, and outside any block, we're going to declare a few variables. We're going to declare X here. We're going to declare Y inside the case 0. So we're going to declare Y, and we're going to go in case 1 and declare Z. Okay, notice that we're not initializing these variables. We're going to try that out in a minute, and we're going to see how this works. For now, we're going to take things step by step, and we're going to do an int u in our default block here. First, let's see if we can compile this. So we're going to bring up our terminal so that we can see the result of our compiler, and we're going to compile. The build is going to be good. Okay, one thing I want to prove here is that each switch block is really one giant scope. So we have int x declared outside any block, but we can use that in case 0. So for example, we can say x equals 6, and this is going to compile. We can even increment it. We can do really all kinds of crazy things. Even if we print this out, it's going to work. So let's do x, and it's going to say x stdendl. You're going to see that Visual Studio Code is happy, and if we build this, the build is going to go through. Okay, this variable x is declared outside any case, but we are able to see it. Now what we're going to do is try to use y in another case, and we're going to do that in case 1 here. So we can say y equals 5. We can do that, and we can even print this out. So let's do y, and we're going to print y. And this is going to compile. If we compile this, the compilation is going to go through, and if we run it, whatever case we have selected here is going to run. In this case, we're going to run case 0, and we're going to see the output. So let's try and run this, and run Rooster. You see that x is 7, statement 1, statement 2, and moving on. And y is x7. We set it to a 6, and we incremented it here, and we're going to print a 7 because that's 6 plus 1. Hopefully this makes sense. The one thing you have to be careful about is not to try to use a variable before its declaration point. So for example, if we try to use a z here and say z equals 6, for example, this is not going to compile because the declaration point of z is in case 1, and case 0 is in front of case 1. So you can't really try to use z before its declaration point, and this is what I mean here. Now let's jump to our default case and try to use z. It's going to work, so we're going to say z equals 10, for example, and this is going to compile. If we try to compile again, the build is going to go through, and this is working. Okay, by now it should be clear that variables in a switch block are really in one scope, and we can really use them across different cases, provided we don't try to do that before the declaration point of the variable. But one thing we haven't really done is initialize a variable. So let's try to initialize x here. If you try to make it a 9, for example, and wait for Visual Studio Code to catch this problem, I don't know if it's going to catch it, but if we try to compile this, we're going to get a compile error. And this error can be really hard to understand. In many compilers, you see here, the compiler is saying main CPP 22, the line 22, where is 22? 22 is here, case 1. So it is saying jump to case label, crosses initialization of int x. So what this is really trying to say is that we tried to initialize this variable. Again, code here is never going to run because in a switch, we're going to run code that lives within different cases. So code here is never going to run. So this variable is never going to be initialized to 9. And this number is basically never going to be used. So the compiler is stopping us from doing that because it is pointless. Unfortunately, errors from compilers can really be hard to understand sometimes, but the longer you do this, the better you're going to become at really making sense of this gibberish you see here. But again, the compiler is stopping us from trying to do a mistake because the 9 value we put in here is actually never going to be put in there because this code is never going to run. Okay, so we can comment this out actually and bring it back to int x so that code keeps running. Let's try and initialize y and see what happens. So we're going to initialize that to a 5. And if we try to build and run, we're going to build with GCC again. And notice that we see the same problems. And why is that? It is really the same problem. So even if this code here to initialize y lives in a case block, there is no guarantee that this case is always going to run. So anybody who would really want to rely on this might find garbage in there because if this case doesn't run, we won't have any useful value in y. And the compiler is really stopping us from making this mistake again, trying to do our initialization in a place where initialization code may never run. And the compiler is going to stop us from doing this again. So if we comment this out again and use whatever we had before, this is going to work. If we try to build again, the compiler error is going to go away. You see that the build is clean and everything's fine now. Don't be misled by these errors we see here. It is because the terminal really keeps all these things in. But if we clear and build again, we're going to see that the build is clean. And if we run this, we're going to see whatever we expect. We see statement 1 and 2 and x is 7, which is what we really expect here. Again, I showed you these things for your own awareness of these things, but don't really try to declare variables that are going to be shared between cases and do that inside your switch block because that's going to be a recipe for disaster. What I would recommend is if you have a variable that you want to be visible across cases, you would use an initializer. For example, put that variable in a data variable like this and put in a 7 and do something like this. And this data variable is going to be visible across all the variables. If you want to use more, this is really not going to be enough for you, but you still have the option to declare and use variables outside the switch scope. So if you say my var and put in a 4, for example, you're going to be able to use that inside any case. For example, here we can say my var ++, and this is going to work. And this is much cleaner because somebody knows we have one point of control for this variable, and it is really easy to follow. What I recommend to use your switch statements is to use your initializer like this, or even an outside variable like this. And remember to wrap your cases inside curly braces because that's going to make your code easier to follow and read. One thing I should really mention is that if you put curlies around your cases like this is going to introduce a nested scope, and code inside a case is no longer visible in other cases. So that's something you should really know. If we do something like this, the variable y is no longer visible in other cases. You see that we have a problem here because this becomes a nested scope, and variables declared in this block scope are not going to be visible outside these curly braces. So that's something you should really keep in mind. Let's bring this back to what it was before so that we can get rid of these compiler errors. I just wanted you to be aware of that. Okay, this is really all we set out to do in this lecture. I hope you don't find it confusing. If you have any problem, please do ask. I will do the best I can to help out. For now, we're going to stop here. And in the next lecture, we're going to try and recap what we saw in this chapter.